Hello, my name is Henning and I'm representing our team FH from the Fachhochschule Dortmund. This presentation will be about the GermEval task 1, and after a short introduction to the two subtasks and their datasets, we will take a closer look to the methods we used and on how they performed. So the first subtask was to predict the measures of cognitive and motivational style. The goal behind this task is to explore potential alternatives to the numerus clausus. And the dataset contains different measurements, which are a few grades and two different intelligent quotient values. We refer to these different measurements as different targets, and it was evaluated how well the predicted student ranking was. And this ranking is only artificial because predicting academic development is still controversial. So for the second subtask, the classification of an operant motif test was evaluated. So the goal was to label the textual answers to images on the level of a psychologist. And the answers are mainly in German language, and the model should be able to classify between 5 different motives and 6 levels. So for the data sets on the first subtask, it was obtained by Nordakademie, and they collected these motive index answers during applicant tests. And we have 80% of the data set for training, and then we have 10% for the development set and another 10% for testing. For the second subtask, over 14,000 volunteers were asked to describe 15 provided images with implicit motives, and these answers have then been labeled by researchers of the University of Trier. And we also have 80% for training, and then the rest is for development and testing. For the preprocessing in subtask 1, the text is vectorized using TF-IDF, and no further preprocessing was applied because at that time our focus was on the second subtask. And for the second subtask, we found 13 documents without a label. So these documents have been removed. We found one label which needed a fix. And when we explored the data, we found that some samples were in French or in English. So to find out how many documents are affected by this, we used a fast text model to detect different languages. And this returned in finding 303 French and 158 English documents, which were then translated into German using the Marian MT Helsinki NLP models. And also for preprocessing, a combination of two spell checkers was used to correct spelling mistakes. And for the non-transformer architectures, the documents were also vectorized using TF-IDF. And we also used the Luke features, and we obtained them through the German version of the analysis tool. And the features were selected performing the chi-squared selection. We also tried a few other different preprocessing techniques, like removing punctuation or replacing German umlauts and ligatures, but this didn't improve results much. So for the methods of the first subtask, we tested a variety of models, a few traditional ones like random forest and also linear regression, but we also tested gradient boosting, and we also used a BERT model with a regression output layer. So this table shows the Pearson results for all of our models on all different available targets. And as you can see, there's no specific target performing good on all models. And at this time, we didn't combine the different grades. We always used just one of them. But after the competition ended, the 3 submitted models we used were re-evaluated with using the sum of all available targets. And this improved the results a lot, as you can see in the right column. So the XGBoost model profited really good from this approach where all the targets were summed up to one value. For the second subtask, we tested a support vector machine as the baseline. We also tested logistic regression and fast text, but we found out relatively quick that the transformer architectures performed well on this task. The winning model of this subtask was a BERT model pre-trained on German text. It is provided by the MDZ digital library team at the Bavarian State Library, and it was pre-trained on different datasets such as the Wikipedia dump and the open subtitles dataset, and also some websites were crawled for this. And all this results in a dataset with a size of 16 gigabytes and a lot of tokens. This table shows the results for the second subtask, and the top 3 models have been submitted by us. And on this task, the transformer architecture models were superior to the traditional models. And as you might notice, there are a few models pre-trained on English text. For example, the BERT base case model. And for these models, the entire dataset was translated to English. And when we explored the translated documents, the translations were good. But as you can see, these models could not compete with the German-based models. So some information was lost during the translation process. The preprocessing when applying a spell check and also translating English and French documents to German only increased the results a little bit. So it can be assumed that the transformer architecture is quite robust against a few bad samples. This image shows the confusion matrix of one of our BERT models. And you can see the predicted class in comparison to the actual class from ground truth. And we found that the motifs M and F are often mixed up, as you can see here. And also that some classes were missed by only 1 or 2 levels, while the motif was predicted correctly. Our conclusion for the first subtask is that no model provided the best results on a single target. And also in this task, the BERT models did not compete with the traditional approaches. This can be investigated in the future. Maybe some parameters were not set correctly on the BERT model. And also the sum of all targets pushed the results quite far. So this seems to be more appropriate for this task. Our conclusion for the second subtask is that transformer architectures worked well for this task. We were able to achieve the highest score out of all submissions. And as we have just seen in the confusion matrix, the motif M and F get mixed up quite a lot. And this behavior should be further investigated in future work. It's also notable that the merged class models perform better than having a single model for the motif and multiple models trained on each motif level combination. Okay, thank you for your attention. I'm available now to answer some of your questions, and you can also contact us by mail if you want.